we will be going through basics of what electrical testing is. This is a digital volt ohm meter. They call it a DVOM, digital volt ohm meter. This kit is something I got off the Mack truck. This was about $400, I think, at the time. Now you can find this brand new for about $250, sometimes a little bit less. Used about $150 for the kit. So it's got a amp clamp. What's going on, Zach? Got a amp clamp kit that hooks into your meter. It also has a temperature probe that hooks into your meter. It's got an updating USB cord. It's got two different sets of leads. There's one regular set, and I've got the other set that's on it right now. And then in the pouch that comes with the DVOM, you get a couple different styles of alligator clips as well that your DVOM plugs into. Good morning. Good morning. Can you guys tell me what the difference between voltage, or what is a voltage drop test? Can you tell me what that is? Do any of you know what a voltage drop test is? Don't look it up, don't Google it. If you don't know, just say you don't know. And then we'll talk about it. What is a voltage drop test? Also, while we're looking at this, I'm going to move this out of the way. This I got from an old man that was retiring from the field. It's a 54-piece automotive connector test kit. It's got different pins that you can use to hook into electrical connectors to test things. It's got big, small, male, female. It's got different plug-in styles. It's got spade styles. It's got all kind of different styles. It's got a, if you're wanting to grab a wire and hook into it, you can with these. Another way, good morning, another way to see resistance amperage or lack thereof. Yeah, but I'm looking for the exact definition of what a voltage drop test is. And what I'm going to do is I'm just going to give you the answer, because we may not have people that know the exact definition. What a voltage drop test is it's testing the difference in voltage from point A to point B. So if I'm supplying 12 volts to this side over here, theoretically I should be getting 12 volts to this side over here. But when I hook my meter up positive on this side and negative on this side, why is it that I get zero? Well, I get zero because I'm losing zero voltage across this wire. It's measuring the difference from point A to point B. And if there is no difference, that means it's got good flow. It's got good connection. So one way that I demonstrate this is, this is the 12 volt garden battery. So let's go ahead and test this to make sure we got good voltage. We're going to put this, no, not parasitic draw either. Parasitic draw, I'll show you what that is. There's actually a couple different. Parasitic draw is one thing. Surface discharge is another thing. We can cover all that stuff, but right now we're just going to look at voltage drop. Voltage drop and load testing are the two best ways to test any circuit outside of the computer on a automotive application. So I've got my meter set into voltage DC. You can see here. Even if I put it in the other one, it will still give me, because this is a smart meter, it knows how to generate. But you can see I've got it over in the straight line voltage. So then what I can do is let's test for battery voltage. Positive to the positive. You can go the other way too. It just gives you a negative symbol. Here. Are we not? Are we mixed up again? Come on now. Alright, it's doing it again. We'll go to auto. Alright, there we go. We got 12.53 volts. A perfectly charged battery is 12.6 volts. There's 6 cells in a 12 volt battery, and each one of those cells have 2.1 volts, which comes out to 12.6. So this is almost a perfectly charged battery right here. Now, let's see what I have available to this red wire here. So I go to the end of the red wire to an alligator clip. You know what we'll do? We'll do like this. Let's see if these will. Those won't work either. Anyway, I was gonna put an alligator clip on them, but I won't do that. So move this a little further back so we can see more. And then if I check what type of voltage is present at the end of this wire, I take my negative, stick it over to negative side over here, and I take my positive, stick it to the end of that wire. Well, there you go. I've got 12.53 volts, which is source voltage, battery voltage. But now if I want to actually see what I'm losing across this wire, I would go like this. Here and here, and look what my meter reads. 0. 0.001 is 0. So that means I'm losing nothing across this wire. Now, if I was to take a load and put it in place, or let's just say this wire was connected to this wire over here. Let's say we had that wire there connected to this wire here, and then it was broke in between. There was an open. But this wire leads back to ground. So let's just do this here. So let's just say we had a complete connection, power flowing, all of a sudden it goes through the load, and then don't use lipo, just let me do my thing. I'm not looking for say this wire was a connection through the. You see it lit up. There's a complete connection here. Come on. There's a complete connection here. The light lights up. Now let's just say somebody pinched this and broke this wire. And I want to figure out from this point to this point down here that goes back to ground. The point down here at the connection that goes back to ground. I want to figure out what I'm losing across that wire. Trying to get this to where it doesn't keep coming out of there. So there. So I've got my connection back to ground. But now I want to figure out what the difference is where my broken wire is from point A to point B. So if I know from here to here, I have 0 volt drop. But if I go from here to here, the side of the load that's going back to ground, let's see what I got. There we go. So now I'm in the load ground, the side going back to ground, which is through the load back to ground. Notice how my light is not lighting up, but I have 12.49 volts here. I just voltage dropped this circuit and proved it out that I'm losing 12.49 volts on this circuit. It should be reading 0. I'm not asking for that right now, Felix. So either you guys stop repeating that or you're going to be booted from the chat. I'm trying to show the difference between a voltage drop and a load test. So please be respectful or you'll be gone. So that basically is a voltage drop. It's from point A to point B. You should be losing 0 voltage on a given segment of supplied power. Now, is it completely accurate? No, it's not completely accurate. Why is it not completely accurate? I was talking to a guy that was really... So it's where a voltage drop test becomes inaccurate is, let's just say we had a really big load on this circuit. Like there's a big heavy duty load. It's pulling 10 amps or whatever, 15 amps to make it actually work plus. And let's just say, for instance, this is a really thick wire. So one of these little strands will light up this light bulb. If I had a thinner wire, I could demonstrate this a little bit more clearly. But let's just say only one little wire out of this whole thing was connected to this over here on this side. But the rest of those strands were not connected. So if we just did one little strand up here and we tested for voltage drop across that, we're going to see 0 still. Even though all these other wires are mangled up and pinched somewhere and they're not connected, we're still going to see 0 drop in voltage. This is where a voltage drop is flawed. So if I go from here to here, up at the top, see, I've got 0 volt drop. So theoretically, this would tell me I have a good circuit. That's not a good circuit. If I had a heavy load on that, just those 2 little strands of wire connected up here wouldn't be able to carry enough amperage down to the actual load to make it work. Load testing is the best way to test any circuit, period. But you have to load test in a manner that's respective to the wires that you're using. Load testing can also fail. So say I came in here and there was a fan or something that ran off the circuit here, and I only had one little strand of wire hooked up. Let's just hook up one little strand of wire to one little strand of wire. Let's actually twist it together, hook it up. All right, you see it's just hanging by one little strand right there, right? Now, what we'll do, that one little strand, and let's just say we bring out our light bulb like we always do. This is a 9006. Exactly. The circuit will still work, but when loaded, it won't. Now, here's where this fails. If you don't have a respective testing device, a load device, to actually test the circuit, Even a load test can fail. Even though a load test is actually more accurate than a voltage drop, if you have like this big thick wire like this, where each one of the little strands are really thick inside, and you've got a smaller load like this, that one strand of wire can still light this light. So I'm not actually load testing this in the correct manner. It should be load tested. I should have a load on these wires that are respective to the circuit that operates on it. So only one little strand here. I got my ground hooked up over here, like even half my ground. I'm not even all the way. Now I'll show you how inaccurate this can be. See that light? It lights up. Why? Because these strands of wire are really thick. And they're large enough, just one single strand, to carry enough amperage to load this up. Now if I had an automotive fan, like a radiator fan or something like that, that I wanted to hook up, or an EGR or something, and I hooked it on this circuit with only one strand connected and load tested it with something that's respective, that's assimilated the circuit load itself, I would be able to test that accurately. So you need to figure out what you're working with. You need to know the circuit you're working with, what type of load it typically carries, and then use something of similar load to actually test that circuit. If I came in with a test light like everybody else does, which this is part of the diagnostic that fails in the automotive field. People have all these lights sitting around. They're like, oh, I'm going to load test it with this light. Yeah, sometimes that works. Sometimes it doesn't. I just demonstrated one little thin strand of wire can carry enough current to load test this. But if I stuck a radiator fan or something on here, the thing wouldn't move. It wouldn't be able to carry enough current to do anything, or it'd burn the wires up. Now you see where I'm going with that? You need to load test with the respective load that assimilates the circuit you're testing. It doesn't necessarily mean that it's high resistance though either though, because let's just test this real quick. I'll show you. Put this in our resistance meter here, and we'll go one little strand. We're going to touch one little strand, and we're going to go to the other side. There we got our one little strand there. I'm touching the end of it there. Let's see what it reads. 0.2, 0.3. I'm trying not to touch it with my skin. Let me put it down and try it. Because touching it with your skin creates resistance as well. There you go. With me not touching it with my skin, 0 ohms. From one strand of wire over here to all the strands of wires over here, indicating there's no resistance loss. So testing resistance on a circuit necessarily isn't accurate either. Load testing is the best way to actually test a circuit. Voltage drop kind of confirms. You can confirm with voltage drops based on the circuit and the type of load that it's carrying. You know, you can try to prove yourself out. And if you keep proving yourself right, then obviously you figured it out. Another thing that you can do is, somebody was talking about parasitic draw. Parasitic draw is after you shut the vehicles down and all the accessories and stuff go to sleep, why is there something still pulling power from the battery? Why are one of the modules or something still alive? It's because there's something in the system that's still active whenever you shut it off. I would give an example of a 2010 Ford Escape. Came in a couple years ago, and I didn't really have very much experience working on the Ford Escapes. One of the senior techs in the shop said, what do you got that in here for? It was kind of before my time. And he says, oh, it's a parasitic draw that you're looking for. And he's like, oh, check this spot and then check this spot and let me know what you find. Well, sure enough, I get my thermal gun out. The vehicle's off. It's been sitting in my stall for like 2 hours. And I get my thermal gun out and I go up to the back glass and I touch the glass where the motor goes through the glass on that unit. And it's super hot. Get my thermal gun out and the imaging says 2 hours later that back wiper is still active. It's trying to park and it can't park because there's so much corrosion and rust buildup back there that whole motor assembly and stuff needs to be replaced. But it's still trying to get into the park position because that's what the logic says from the computer it's supposed to do. It's supposed to park and then shut off. Well, because it can't park all the way, it's not shutting off and it drains the battery. Thus, you get a parasitic draw. Now, there's another type of a discharge from a battery. It's called surface discharge. Here's your battery. You notice how some batteries have a lot of fluid and stuff that goes across the top of it, and it'll just be spilled and dusty all across the top? Well, that actually discharges battery voltage. That actually discharges the battery, letting all that debris and stuff sit on top of that, because it actually makes a path for current to flow from positive to negative. So you would like go to your negative post. Let's just say go to your negative post, and then you'd take your positive probe and you'd test different spots on the case in that fluid. And you just walk your way around the top of the battery, and you'll see if you start reading some kind of voltage up here, what that's indicating is you're discharging voltage from the top of the battery through all that nasty acid that's spilled and debris and stuff that's left on the top of it that's causing this connection between the two posts that's causing the battery to discharge. So, I mean, I don't know what else you guys would like to learn. I don't use resistance checks anymore unless I'm just doing something quick, just to kind of get a feel for. I would use a resistance check on like this if I didn't have the ability to load test it, or I just wanted to see what it is. Sometimes these filaments inside here break and they fall down. They'll still make a connection. They get real hot, they'll burn up. They'll still discharge voltage from the system, but it won't work properly based on how it fails. So if I wanted to, anytime you do a resistance check, you want the system to be depowered. You don't want power on that line. So put it in resistance, that little horseshoe, and then I go positive to positive, negative to negative. It really doesn't matter. If there's no power, you can test it however you want. This here is telling me, and this light, I have 0 resistance. But if I was to take let's check this here. If I was to test from one end of this temperature probe to the other, I've got 4.5 ohms of resistance from one end to the other. So I could see if I had a complete connection with a resistance check, but it doesn't necessarily mean I have a good resistance check. That's why I always go back to voltage drop and load testing. Load testing being the main primary function of how to test an electrical circuit. Now you can load test a electrical circuit that is hooked up to the computer. So if it's a verifiable source and you're using, like a 12 volt supply wire to a sensor or actuator or something like that, you can unplug that actuator and then take the pin that is your supply wire, grab one of your leads over here, pin into the connector, come back out the other side here, and take your load and test from one side to the other through like the power supply coming out of the connector into this pin, from this pin into your load, from your load back over to ground. And if this lights up, you know you got good power supply. And you got a good ground circuit as well, because that ground is able to carry that load back to ground. So you've just tested your positive and your negative wire out by doing it that way, and the supply from the computer. So if you've tested your power and your ground and the computer supply, and it was able to carry that load and that current, you know those three things aren't your issue. But if it's more than a 2-wire circuit, it could be the actual thing itself that you're trying to power, like an EGR or a cam sensor or something like that, looking for a signal or reference voltage back. Then you're going to have to load test the 3rd wire as well, or the 4th or the 5th, just to make sure you got good circuit going back. And how I would do that is the same way would be load testing. So the tools that we used today is the EM721 from Mac, and a electrical probe kit over here, or pin kit over here on the side, and just a regular 12 volt 230 cold cranking amp garden battery, just for testing purposes. I know there are better batteries out there than this and stuff like that, but that's not what this video was about. This video was about basically giving you guys the definition and explanation of why I prefer load testing over voltage drop, because a voltage drop can lead you down the wrong path more than a load test can. But then when you load test, you also have to know, in respect to the circuit you're testing, what type of load you should be using. I have a box at work that it puts a certain amount of resistance on a circuit it's old. It's from back in the late 70s, mid 80s, and you take this box with a dial and you turn it to these different resistances, and if you know what the resistance is of a circuit, you can put that resistance in, and at that point you can hook that up through your circuit, and actually through load testing, it'll create a load. You can test and see what you're dropping, what you've got available, what's coming out the other side if the circuit's not good. So there's a couple different ways to do it. Voltage drop testing and load testing isn't the end-all be-all, but they are the best things that you can use to test electrical circuits. Again, if we ask the same question we did from the beginning, what is a voltage drop test? It's the difference between point A to point B. And if I was to say, what is a load test? It's using a specific circuit to supply power down that circuit through a load back to ground to make sure the circuit actually operates correctly with respect to the load that's supposed to be on that circuit. So that's what I got for you guys. Anybody else have any questions before I get out of here? I wanted this to be quick, kind of to the point, and that's how I load test and voltage drop test. Midwest F-150, appreciate you, brother. What's up? Go ahead. Yep, baby's doing good. She's doing real good. Okay, all right, I'm going to take off, guys. I appreciate you being here, and I hope this helps somebody in the future. If this has helped you, if it's refreshed anything, leave me a comment down below. Subscribe to the channel and share it with somebody. Thank you. Be blessed.